While most Americans were debating electric vehicle range and charging times, a quiet industrial revolution was unfolding in the desert of Texas. Tesla wasn't just building another factory, they were dismantling a century-old playbook that every automaker has followed, creating something that has sent shockwaves through boardrooms from Detroit to Stuttgart to Beijing. What started as Elon Musk's ambitious battery announcement has evolved into something far more consequential, a complete reimagining of how cars are made and who controls the supply chains that power them. To understand why Tesla's battery strategy has the entire auto industry scrambling, we need to step back and look at how car manufacturing has worked for the past 100 years. Traditional automakers like Ford, General Motors, and Volkswagen operate on what's called the supplier model. They design vehicles, but they don't make most of the parts themselves. Instead, they rely on a complex web of suppliers, companies that specialize in everything from seats to semiconductors to, crucially, batteries. For electric vehicles, this means automakers are completely dependent on battery giants like CATL from China, LG Energy Solution from South Korea, or Panasonic from Japan. These suppliers hold enormous power because they control the single most expensive component of an electric car, the battery pack, which can represent up to 1/3 of the vehicle's total cost. Tesla looked at this system and decided to do something radical: build their own batteries. Not just assemble battery packs, but actually manufacture the individual cells that go inside them. This decision seemed almost reckless when Tesla announced it during their 2020 Battery Day event. Industry experts dismissed Musk's claims as overly ambitious, pointing out that battery manufacturing is incredibly complex, requiring specialized knowledge that takes decades to develop. The consensus was clear: stick to what you know, let the battery experts handle batteries. But Tesla had been quietly preparing for this moment since 1919, when they acquired a small company called Maxwell Technologies for $218 million. Most people had never heard of Maxwell, but they possessed something revolutionary: dry electrode technology. Traditional battery manufacturing uses what's called a wet process, where active materials are mixed with toxic solvents to create a slurry that's then coated onto metal foils and dried. This process is energy-intensive, environmentally problematic, and creates production bottlenecks.
Maxwell's dry process eliminates the solvents entirely, using advanced polymers to bind materials directly. The implications are staggering: 47% less energy consumption, faster production times, and the ability to create thicker electrode coatings that store more energy. For years, Tesla struggled to scale this technology. The dry process worked in laboratories but proved incredibly difficult to mass produce. Industry watchers began to wonder if Tesla had bitten off more than they could chew. Then, in 2024, something changed. Tesla's engineers finally cracked the code. They mastered the dry electrode process for both anodes and cathodes, achieving what their director of cell manufacturing operations called the lowest cost per kilowatt-hour of all Tesla's battery cells. Suddenly, Tesla wasn't just making their own batteries, they were making them cheaper than they could buy them from suppliers. The numbers tell a remarkable story. Tesla's Austin Gigafactory now produces enough 4680 battery cells weekly to support over 250,000 vehicles annually. These aren't just any batteries, they're fundamentally different from what everyone else uses. The 4680 cell, named for its 46mm diameter and 80mm height, stores 5 times more energy and delivers 6 times more power compared to traditional cells. But the real breakthrough isn't in the chemistry, it's in the manufacturing process and what it means for costs. While external suppliers charge around $100 per kilowatt-hour for battery cells, Tesla's internal production costs have dropped to as low as $70 per kilowatt-hour. For a single Tesla Model Y, which contains 830 of these cells, this cost difference translates to thousands of dollars in savings per vehicle. But Tesla's advantage goes beyond just cheaper batteries. Because they control the entire production process, they can iterate and improve rapidly. When they discover a better manufacturing technique or a materials improvement, they can implement it immediately without negotiating with external suppliers or waiting for industry-wide adoption. This vertical integration strategy extends far beyond just battery cells. Tesla controls approximately 80% of their supply chain, from lithium refining in Texas to final vehicle assembly. They've built a closed-loop recycling system that recovers over 90% of key materials from used batteries, reducing their dependence on raw material markets. Most importantly for American interests, they've created a domestic supply chain that doesn't rely on Chinese processing facilities, which currently control over 80% of global battery-grade lithium processing. The geopolitical implications cannot be overstated. Every other American automaker depends heavily on Chinese battery suppliers or materials processed in China. CATL, the world's largest battery manufacturer, supplies 37% of global EV battery capacity and has deep ties to the Chinese government. When trade tensions escalate or supply chains face disruption, these automakers become vulnerable. Tesla's domestic approach offers something that traditional automakers cannot provide: energy independence at the automotive level. The industry's response has been nothing short of panic. In 2020, when Tesla announced their battery plans, competitors dismissed them as unrealistic. By 2024, as Tesla demonstrated actual production capabilities and cost advantages, the tone had completely shifted. General Motors announced massive investments in battery facilities at their Warren, Michigan tech hub. Ford moved battery production for several EV models, including the F-150 Lightning, from Poland back to Michigan. Rivian committed $120 million to supplier parks specifically to support battery production scaling. These aren't strategic investments. They're defensive moves by companies that suddenly realized their supplier-dependent model leaves them fundamentally vulnerable. Even Chinese battery giants are feeling the pressure. CATL's chairman, Robin Zhang, publicly criticized Tesla's 4680 technology, claiming their own batteries are superior, the kind of defensive statement that reveals underlying concern about competitive threats. LG Energy Solution has begun piloting dry coating technology, but their full-scale production won't begin until 2028, putting them 4 years behind Tesla's current capabilities. The technological gap is widening rather than narrowing. While competitors struggle to master dry electrode technology, Tesla is already developing next-generation battery chemistries. Industry rumors suggest they're exploring aluminum-ion technology that could offer dramatically higher energy density and faster charging times. Whether these rumors prove accurate or not, they demonstrate something crucial. Tesla has established themselves as the technology leader, forcing everyone else to react to their innovations rather than setting their own direction. But Tesla's battery strategy goes beyond just manufacturing advantages. It's reshaping entire business models. Traditional automakers sell through dealership networks, negotiate with suppliers, and operate on relatively thin profit margins. Tesla's vertical integration allows them to sell directly to consumers, maintain higher margins, and create integrated ecosystems that span electric vehicles, home energy storage, solar panels, and charging infrastructure. Their energy storage business alone expects at least 50% year-over-year growth in 2025, leveraging the same battery technology used in vehicles to create additional revenue streams that pure automotive companies cannot match. The broader implications for American industrial competitiveness are profound. For decades, American manufacturing has followed the supplier model, outsourcing specialized production to focus on design and assembly. Tesla's success suggests this approach may be fundamentally flawed for critical technologies. When key components like batteries become strategic assets rather than commodities, controlling their production becomes essential for maintaining competitive advantage and national security. Traditional automakers now face an impossible choice. They can continue relying on external suppliers, accepting cost disadvantages and supply chain vulnerabilities, or they can attempt to replicate Tesla's vertical integration, requiring massive capital investments, years of technology development, and fundamental changes to business models that have worked for decades. The companies attempting hybrid approaches, joint ventures with battery suppliers, or limited in-house production may find these partial measures insufficient against Tesla's comprehensive integration strategy. The stakes extend far beyond individual company competition. This represents a potential shift in how America approaches advanced manufacturing. If Tesla's model proves superior, it could influence everything from semiconductor production to renewable energy manufacturing. The question isn't just whether Tesla can maintain their battery advantage, but whether American industry more broadly should embrace vertical integration for strategic technologies. Looking at production capacity projections, Tesla plans to reach over 100 gigawatt-hours of annual battery production by combining their internal facilities with strategic supplier relationships. This gives them supply security that competitors dependent on external allocation cannot match.
When battery suppliers must divide capacity among multiple automaker customers, Tesla's internal production provides guaranteed supply for their own vehicles, while competitors compete for remaining capacity. The environmental implications add another layer of complexity. Tesla's dry electrode process eliminates toxic solvents, reduces energy consumption, and cuts factory footprints by up to 10 times compared to traditional wet processes. As environmental regulations tighten, these manufacturing advantages could become regulatory necessities rather than competitive choices. American automakers following traditional supplier models may find themselves disadvantaged not just economically, but environmentally. Tesla's approach also demonstrates how technological innovation can address geopolitical vulnerabilities. By building domestic supply chains for critical technologies, they've created a model that other American companies could follow. This becomes particularly relevant as tensions with China continue to influence trade policies and supply chain strategies. Tesla has shown that American companies don't have to choose between cost competitiveness and supply chain independence. With sufficient innovation and investment, both are achievable. The human capital implications are equally significant. Tesla's battery strategy has created thousands of high-skilled manufacturing jobs in Texas, Nevada, and other American locations. These aren't just assembly jobs, but engineering, research, and advanced manufacturing positions that represent the kind of work America needs to maintain technological leadership. Traditional automakers, by outsourcing battery production, have essentially exported these opportunities to other countries. As we watch this transformation unfold, the broader question emerges. Is Tesla's battery strategy a glimpse into the future of American manufacturing or an isolated success story that others cannot replicate? The answer may determine not just who dominates the electric vehicle market, but how America competes in advanced technology manufacturing more broadly. The auto industry's fear of Tesla's battery strategy reflects a deeper recognition that the rules of competition have fundamentally changed. In a world where supply chain control, manufacturing innovation, and technological integration determine competitive advantage, Tesla has demonstrated that the traditional playbook may no longer be sufficient.
Whether American industry embraces this lesson or continues following outdated models could determine the country's manufacturing competitiveness for decades to come. So the real question isn't whether Tesla's battery strategy will continue succeeding. The data suggests it will. The question is whether America's industrial leaders will learn from Tesla's example and embrace the kind of vertical integration and manufacturing innovation that could secure competitive advantages in other critical technologies. What do you think? Is Tesla's approach a model that American industry should follow, or are there risks to abandoning the supplier relationships that have worked for so long?